Good morning to everyone. We completed all the 5 units of discussion, but within few days you are supposed to go for your final exam. It is very difficult for you to refer the entire notes in the last 1 or 2 hours of your exam. So for that you need to prepare a short notes which gives an complete idea of an unit. Okay, for example, if I prepare a short notes for a 1 unit, I need not to refer the entire my notes. Okay, entire my first year note, first unit notes. Just if I refer further my short notes for a duration of 1 to 2 minutes, I can get an idea about this. I'm mean to say this is only for the candidates who already prepared the who already prepared the things. Okay, so without knowing anything, if I refer my short notes, I can understand the thing. Is it not the concept? Already you prepared, but for last minute references, you just go through your short notes. So the main point here in today's discussion is how to prepare a short notes for a unit. So for unit number 1, okay, for unit number 1 I'm going to discuss the short notes. Okay, so already we have this. So the first part will covers your DC excitations and second part will covers your AC excitations. If we make it as a simplify, under AC and DC, under AC and DC excitations, we have Theligen's reciprocity, maximum power, milliamps, and compensations. For only AC excitation, we have the superposition, Thevenin's, and Norton's. So now we will see how to prepare a short notes. So please remember only one point: the short notes will be around half page or less than half page. Don't make the short notes of 10 to 15 pages. It's not to be elaborated, it just gives a crisp idea of your concept. That's the thing. So now now I'm going for unit number 1. So under unit number 1 we have the AC excitations and DC excitations. I start with DC, simultaneously I go for the AC excitations. So the theorems which comes under the DC excitation I referred here. For AC I just go for. So when you go for the DC excitation, remember only one point: you have a simple magnitude there, no need to convert any value here. But when you go for the AC excitation, you have the magnitude as well as phasor. Here you having some little bit calculations. So for example, if the source, if you are supposed to do the mathematical calculations for AC excitation, if it is in a division, okay, if it is in a division, magnitude to be divided and the polar quantity need to be subtracted. And similar way, if you need to multiply magnitudes will be multiplied and phasors will be added up. So this is common for all the AC excitation problems. At the same time, you need to do the practice of your calcs also. How you keep your calcs. So practicing of calcs is must. So you need to go with complex and to place the mode. Whether your answer is need to be in polar or rectangular, you have to go for the shift plus mode. There you go for the complex, and the rest of the things you need to be performed by practicing. Okay, it will be understand only by practicing. So under the AC excitations, okay, under the AC excitation I start with superposition theorem. In superposition theorem okay, in superposition theorem, what is the concept behind the superposition theorem? So if you are having more than two sources in your circuit, if you are having more than two sources in your circuit, you need to be considered only one source at a time. You need to be considered only one source at a time. Okay, one source at a time. At the same time, the not considering positions, that means, for example, if I'm having the voltage source in my circuit, voltage and current source in my circuit, if I'm considering only one source at a time, how the rest of the source will be behavior? Okay, how the rest of the source will be behavior in not considering time? Voltage will be short circuited and current will be your open circuit. So this is not considering position time. You need to be mentioned like this. Okay, assuming your system. So in superposition theorem, finally I can say that the summation of the individual elements, that means in the responses, if they ask the current, you have to be mention the current, or if they ask the voltages, you need to be okay. The responses will be, the individual responses should be equals to the all the sources considerations. So with this I can say the superposition theorem, I need to be considered only one source at a time. Okay, the circuit which is having more than two sources, I need to be considered only one source at a time. The response, okay, the response of individual the response of individual sources will be equals to the summation by the response of all the source at a time. In the rest of position, in the rest of the position, voltage will be assumed as a short circuit and the current source will be assumed as open circuit. So this is about my superposition theorem. When I go for the Thevenin's theorem, okay, whatever the complicated circuit they given, okay, whatever the complicated circuit they may give, okay, I need to be convert in such a way that this is my VTH, this is my ZL, this is my ZTH. So how need to be converted? So this is the given circuit, okay, this is the given circuit, this is the ZL, for example this is the ZL. So try to bring out this. So here this is my rest of the elements after taking out the ZL. So find out ZTH. Here I just want to mention only one point. If they mention which is the ZL, take out that element, there you find out the VTH. So now I find out VTH. For example, if your source is voltage source, short circuit, or if you are having the current source, open circuit, to find out your ZTH. So this is about your Thevenin's theorem. When I go for the Norton's, how I go for the Norton's? Same. For example, the same circuit I need to be considered. So it should be converted in such a way that as IN in parallel with ZTH in parallel with your ZL. Okay. Here I forgot to mention. For example, if they ask the current through your load resistance IL, it is nothing but VTH divided by ZTH plus ZL. Here if they ask the load resistance IL equals to, this is current source IN, by simply applying your current division principle, ZL. Okay. So this is up to here it is coming. So the current is dividing in these two parallel branches. So opposite resistance divided by total resistance. So this is regarding your the finding of your IN will be so wherever the your load resistance are there, wherever the load resistance are there, simply short circuit and find out your IN. Simply find out your IN. So this is your Norton. So I just completed the superposition, Thevenin's and Norton's of your AC excitation. AC excitation means you have to remember this sort of calculations. The calculations will be understand when by you practicing. Okay, we need not to be discussed right now here. Okay, so next I need to go for the AC as well as DC excitation combinations. So now I go for the Theligans. So the simple theorems I start with. So starting with Theligans theorem. So Theligans theorem is nothing but equals to 0. That means, for example, here the circuit is having okay, for here the circuit is having around 1 2 3 4 5, total 5 elements are there. Okay, total 5 elements are there. I need to be calculate voltage and current across each and every element. Okay, voltage and current across each and every element and find out, and I just simply a summation of those things, or the summation of all those things will be equals to 0. Okay, when I ask the Theligans theorem, they ask you to verify. They won't ask you to calculate or something else. They just simply ask you to verify the Theligans theorem. So what you need to do, you need to find out what will be the voltage and current across each and every element you need to be find out. That is your Theligans theorem. Whether it is an AC or DC, this is the way how you are going to calculate. Okay, next one will be your reciprocity. Okay, for reciprocity theorem, how you need to be calculate. So for example, this is my given circuit. Okay, this is my given circuit. This is my source at the source and the source mention. This is my load. Okay, the load, they ask you to find out the current. So you're supposed to find out what will be the current flowing through your load resistance. So what will be the current flowing through your load resistance after interchanging. That means after interchanging means in the place of load you keeping the source, in the place of source you need to be place the load. So you need to be interchange the positions. So here this is the load and this will be your source. Now it will be your IS and this will be your ER. Okay, now you're supposed to find out your IS. The same thing will be placed. Okay, this is your ZL. This is your ZL. You need to be find out IS. So after finding this, the ratio of ES divided by IR equals to ER divided by IS. So by this, like if these two values are equal, these two ratios are equal, I can say that this is superposition. Thevenin's reciprocity theorem is verified. So here also they ask the question, verify the reciprocity theorem. They ask you verify the reciprocity theorem. Next one will be your Millman's theorem. Okay, for Millman's theorem, remember one thing, whatever the complicated networks are there, it will be converted into a simple network. For example, here I am having the voltage sources in series with resistors. When I go for the AC source, I can call it as an impedances. So I need to be convert this one into a single value of voltage and resistor. Okay, single voltage and resistor. For example, this one, if I go for DC circuit. Okay, now I'm called for DC. In DC I call it as a resistor. When it is an AC I call it as an impedance. So I can give it as V dash equals to, this complicated V1, V2, all these things, I1. Okay, so this one I will give it as V1 G1. G1 is nothing but 1 divided by R1. Okay, so V2 G2, so on up to divided by G1 plus G2. Similar way, R dash will be 1 divided by G1 G2, so on. For example, in the same place, if I go with a current source, okay, if I go with a current source, in the current source the resistors will be connected in parallel. Okay, I need to convert this one into a single set. This way of connection is, you may know. So this is R dash and this is G dash. Okay, this will be your G dash. So the way of giving in DC excitation, it will be I dash equals to I1 R1 plus I2 R2, so on, divided by R1 plus R2. When I go for this G dash, it is nothing but 1 divided by R1 plus R2. This is for DC. When I go for the AC, only one variation is in place of G, I replace with admittance Y. Okay, I replace with admittance Y. When it is in current sources, whatever the R is there, I replace with impedance. Okay, my G is nothing but your 1 divided by R. G is nothing but 1 divided by R. Here R is in terms of AC. In AC excitation we call it as an impedance. So R will be replaced with Z. 1 by J is replaced with Y, admittance. So you know that Z equals to 1 divided by Y. R equals to 1 divided by Z. Okay, so G is replaced with Y, R is replaced with Z. So this is about Millman's theorem. So complex will be converted into simple element. So this is my Millman's theorem. So I completed my Theligans, reciprocity, Millman's and compensation. So compensation will be only one point I need to say about compensation. Okay, compensation theorem. Whatever the network they mention, you need to find out what will be the current through the load resistance. You simply find out. In the continuation to the problem, they mentioned that they placed an ammeter or change of resistance will be happened. You supposed to find out what will be the current flowing after the change. So for example, they mention like this. You simply do one thing. In DC, okay, for a DC, you simply find out the step number 1 is find the current of find the current in actual circuit. Second step, find out the current variation. Okay, what will be the change in voltage by the variation of your resistor or by inserting of the ammeter. You find out the change. Then find out your change in current by including delta R. So in the fourth step, you can find out what will be the current variation, delta I. Okay, So this is respect to the AC. So I can get the change current, or you may call this one as an I dash, or this will be the delta I, whatever maybe it is, both are fine. When I go for the AC, what is the variation of delta Z? Okay, with the variation of delta Z, what will be the current flow? I need to be find out. So step number 1, the same thing, find out I. In the step number 2, you need to be find out what will be that delta Z already given in the problem. In the third step, you need to find out what will be the delta, change in current. It is nothing but I into delta Z divided by Z total. So finding the second time current by including the change in resistor. So the final change will be I dash equals to I minus delta I. So this is with respect to the compensation theorem. Now we left over with superposition theorem. We left over with maximum power transfer theorem. Okay, maximum power transfer theorem. In maximum power transfer theorem DC, only one point I just mentioned here. Okay, this is my given circuit. They ask for what value of this resistor, the maximum current is, the maximum power is flowing in the circuit. For DC, I remember one thing, RL equals to RTH. So I need to be find out again VTH. I need to be find out what is VTH and RTH. So the finding of VTH and RTH already you know in Thevenin's theorem. That's why I am not repeating again. So I just considering this VTH and RTH. So this now RL will be equals to RTH value. Okay, RL will be equals to RTH. So IL equals to VTH divided by 2RL. Okay, 2RL. From this, the maximum power P max. Okay, P max equals to VTH square divided by 4RL. Okay, this is for DC. When you go for AC, now the circuit is having ZL. ZL is nothing but the combination of RL plus JXL. Your resistance may be a variable thing or XL may be variable thing. Based upon that, we have some conditions. That is, if the circuit both RL and XL is varying, your ZL will be the complex conjugative of your ZTH. For example, if your circuit is having only RL is variable and your XL is fixed quantity, your now ZL will be your resistor dominating. RL will be equals to ZTH plus JXL. For example, in this RL is variable and XL equals to 0. That means the circuit is pure resistive. Nothing but your DC type of condition. RL equals to mod of ZTH. Now with the circuit both XL and RL is varying, but your theta is equals to constant. At that time your ZL is nothing but it is your ZTH. So by considering even all these things, your maximum power transfer, the maximum power transfer P max equals to VTH square divided by 2 4 RL. So this is my unit number 1 short notes. So while before going to the exam, I just refer these points. No need to refer the complete notes. This is for the candidates who already prepared. Okay, who already prepared. So simply to have a crisp idea about your unit. That's it. So I just prepared a half page. Okay, half page just at a glance. Among all those things, I just want to, so you have the complete idea of theory, but you didn't practice anything about your calci, then it is completely waste. So you need to have the practice of your calcis. So this is about your unit number 1. So better you may divide like this also. So by observing this, I can have better. Okay, for these theorems, I need to prepare for both AC and DC. For AC, I need to prepare these theorems. Just I can finally cross check whether I prepared this theorem or not. That's the thing. Okay, I hope at least for one person it is useful. It's fine. Thank you.